Okay, we have to another integral. This one's from MIT Integration Bee 2023, quarterfinals, round 2, problem 1. We have the integral from square root of e to infinity, x to the minus ln x dx. Okay, to get started with it, the first problem I notice, I don't like having x in the base when we've got an x also in the exponent. Well, we can just correct that. We can write x as e ln x. So if I plug that back in here, what's going to happen with exponent properties? We can multiply the ln x's together and we get e minus ln x all squared dx. But now at this point, if I were to do a u substitution, if I could clean this up right here, this is a lot like the Gaussian integral. If we get the lower bound to 0, this has a known value of square root of pi over 2. So let's see what happens when I do this substitution. I'm going to just set u equal to ln x. Then I can solve for x. We'll get x is equal to e to the u. Take a derivative, then dx is going to be e to the u du. So next we'll go ahead and substitute. First we plug infinity in here. Natural log infinity, that's still going to infinity. Plug square root of e in here. Now let's see what's going to happen there. That's going to be, if I just plug in square root of e for x, let's write it as e to 1/2. But then with log properties, we can take this out front. I can write it as 1/2 ln e. But ln e is just 1, so this whole thing is going to become 1/2, and that's the lower bound. And now we've cleaned up this part, we get our e minus u squared, but with our dx, now we brought in e to the u du. But now at the same base, I can just kind of multiply these together, adding exponents, and I can write this as e minus u squared plus u. And now as you can see, we don't quite have the Gaussian integral, we don't quite have the lower bound at 0, but what I can do is try to just clean up the exponents some more. So for minus u squared plus u, let's factor a minus up front, and we have u squared minus u. And then I'll complete the square on it so that we'll still have something squared, so we can still try to get back to the Gaussian integral. So then completing the square on this, we want half of this exponent, so I'm going to do u minus half all squared. If you multiply this out, you get u squared minus half u gives the minus 1u, but then for the last term we get a plus 1/4, so I don't want to change it. I'll subtract off the 1/4. Then let's distribute the minus sign back in, so I have u minus 1/2, and then this becomes a plus 1/4. Now let's get rid of this stuff here, and then let's just remember what we're doing. This whole thing, this is all of our exponent on e. So what I can do is break this up again. I can write it as e minus u minus half squared. And then this 1/4 I'll break out as a second term, e 1/4. So now let's take this and put it back in the integral, but this part right here, e to the 1/4 is just a constant. So let's pull that out front. And then we've got this part inside the integral, so we have e minus u minus half all squared. And sorry, this should be a half right here. And so now what we notice here is we can do another substitution, trying to get it back to the Gaussian integral. So I'll just substitute, we'll do t right there. So let's see what happens. I'll say t is equal to u minus 1/2. Take a derivative, so dt is just du, real simple. So we'll go ahead with this again. We've got our constant out front, updating the bounds. Infinity is still going to infinity. You plug a half in here, now half minus half, now we get 0. This piece right here, that just cleans up to e minus t squared, du is dt. And that way, what we have right here, this whole integral, this right here is our Gaussian integral, and this is going to be square root of pi over 2. So multiplying it by e to the 1/4, we get e 1/4 square root of pi over 2. This is fine for a solution, but I kind of like the fancy way of doing it. What I'll do is I'll put it all in one square root, and I can write it as square root of pi square root of e over 4, just squaring it. Again, you don't have to do it this way, but I kind of like it. I think also MIT had it this way. So for my final solution, we have square root of pi times square root of e over 4, and that's it. Okay, so there you go. Interesting integral from MIT 2023. Thanks so much for watching. Have a good day.